Good morning, students. In the previous class, I had explained to you about the atoms and the subatomic particles, electrons, protons, and neutrons. And today I will going to explain the discovery of electrons and the discovery of protons. How electrons and protons were discovered. Electrons were discovered in 1897 by J.J. Thomson. He was the British scientist. He discovered electron. But before him, William Crookes, he was British scientist. He was doing some experiment to study the phenomena of electric discharge through gases. As we know, gases are poor conductor of electricity. But he was doing some experiment through gases. What he observed, when an electric current of high voltage was passed through a discharge tube. I am explaining with this diagram. Here is the discharge tube, and this discharge tube is made up of hard glass. Inside the discharge tube there is gas, and one vacuum pump is attached with it, so that the pressure should be reduced. Pressure should be reduced up to only 0.01 mm of mercury. The normal pressure is 760 mm of mercury, that is 1 atmosphere, but here the pressure is only 0.01 mm of mercury. It was connected with a high voltage induction coil, and the voltage was 10,000. There was a voltage of 10,000 volt was passing through it. Initially, when the electricity passed, it was found that some rays were coming out from the cathode. We can see in the diagram, rays are coming from the cathode. Cathode, it is the negative terminal, and anode, it is the positive terminal. As in any circuit, there is positive and negative terminal. So cathode is the negative terminal and anode is the positive terminal, and rays were coming from the cathode. As the rays were coming from the cathode, they were called cathode rays. Later on, J.J. Thomson studied the characteristics of the constituents of cathode rays. On studying, he concluded that cathode rays consist of negatively charged particles present in atom of all the element. In all elements, negatively charged particle are present, and these are called now electrons. So electrons were discovered. J.J. Thomson did some more experiment to know the characteristics of electrons. For this, an electric field was applied in the path of cathode rays. We can see in the diagram, the same diagram. Here, an electric field, it was applied. This is the negative pole of the electric field, and here is the positive pole of the electric field. When electricity passed, the rays, cathode rays which were emitting, they were passing towards the positive pole of the electric field. It shows that it is negatively charged particles. In place of electric field, magnetic field were taken, but the result was same. Now we move to the properties of electrons. Electrons are an integral part of all atoms. That means electrons are present in all the atoms. Its properties are independent of the nature of the gas. Nature of the gas, initially he was taken hydrogen gas, later on oxygen gas, nitrogen gas. Whatever the gas is taken, the result was same. Electron has a definite mass, and this mass is 9.108 into 10 to the power minus 28 gram, which is equal to 1 by 1837 of the mass of hydrogen atom. As per our study, hydrogen is the lightest atom. Its charge is 1 unit negative charge, that is equal to 1.602 into 10 to the power minus 19 coulomb. Coulomb is the unit of charge, and this is considered as 1 unit negative charge. Now how can we represent an electron? Electron can be represented by the symbol, this one, E minus 1 0. Here superscript 0, it represents the mass, and subscript -1 it represents the electric charge. As it is -1, so 1 unit negative charge. Now let us move to the discovery of protons. How the protons were discovered? Actually, it was thought that if in an atom electrons are present, that are the negatively charged particle, then atom should be negatively charged. But it was found that no, atom is neutral. So other particle must be present in the atom. A German scientist E. Goldstein in about 1907, he also performed the same experiment, but he made some changes. What changes he made? In place of cathode plate, he took the perforated plate. Perforated cathode. Perforated, that means there were some holes in that plate. When electricity passed, he found that some rays were coming from the anode, and these rays passed through the perforation of that perforated plates, and they were coming from the anode, so they were considered as the anode rays. Properties of protons. The mass of a proton was concluded that the mass of an atom is equal to the mass of hydrogen. It is 1.672 into 10 to the power minus 24 gram. It is equal to the mass of one atom of hydrogen. Charge. The positive charge on a proton is equal to negative charge of the electron. That means proton and electron both have the same charge. That is 1.602 into 10 to the power minus 19 coulomb. But electron has negative charge 1 unit and proton has 1 unit positive charge. Further experiments prove that all elements are composed of electrons and protons. That means electrons and protons are the fundamental particles of all the atoms. And different elements have different number of protons and different number of electrons. For example, hydrogen. Hydrogen has only one electron, one proton. Helium, it has two. Lithium, it has three, and so on. How can we represent the protons? Protons are denoted as P plus 1, 1. Here it is the superscript. It shows the 1 unit mass. 1 AMU. AMU is the unit of atomic mass, and subscript plus 1 it shows the 1 unit positive charge. So in this way electrons and protons were discovered. Now the question was, what is the position of electrons and protons in an atom? For this, Thomson gave a model of the atom, that is called Thomson's model of an atom. According to him, atom is a sphere of positively charged particles. That means he took some positive charge and make the mixture, and then he made the atom in which electrons are embedded. It is very much similar to the plum pudding. In plum pudding, the whole part is the positively charged and the different things are embedded into it like the electrons. It is also very similar to the watermelon. The whole red part is the proton and the seeds black portion, they are the electrons. The total positive charge of the atom was equal to the total negative charge of electron has 1 unit negative charge and proton has 1 unit positive charge. So atom is considered as equal, that is neutral. An atom would become negatively charged if it gains 1 electron, and it becomes positively charged if it lost 1 electron. But this model failed to explain many experimental observations about the atoms, so this model was not accepted.